So, good morning, dear students. So, myself, Dr. Lingaraju, Assistant Professor of Physics, Government First Degree College, Tumkur. So, today we will discuss in Sound chapter, session number 20. That is in a physics concept, 4th sem, absorption coefficient and Sabine's formula measurement. So last class we discussed buildings measurements of reverberations and also a reverberations time. The continuation of this topic is absorption of coefficient. So here we know the sound absorption coefficient, it is called as A of a material is defined as a ratio of sound energy observed by it to the total energy incident on it. ಒಂದು ರೂಮ್ ತಗೊಂಡ್ರೆ ಆ ರೂಮ್ ಒಳಗಡೆ ಸೊ ನಾವು ಎಷ್ಟು ಅಬ್ಸಾರ್ಪ್ಷನ್ ಕೋಎಫಿಷಿಯಂಟ್ನ ಆ ರೂಮ್ ಒಳಗಡೆ ಮೇಂಟೈನ್ ಮಾಡಿರ್ತೀವಿ, ಎಷ್ಟು ಸೌಂಡು ರಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಆ ನಾವು ಮೇಂಟೈನ್ ಮಾಡಿರೋ ಒಂದು ಅಬ್ಸಾರ್ಪ್ಷನ್ ಕೋಎಫಿಷಿಯಂಟ್ ಮೇಲೆ ಬೀಳುತ್ತೆ. Based on that, here absorption coefficient values here we are going to get it. That values we are getting. ಎಷ್ಟು ಅಲ್ಲಿ ನಾವು ಎನರ್ಜಿ ಸೌಂಡ್ ಎನರ್ಜಿ ಅಬ್ಸರ್ವ್ ಮಾಡುವಂಥ ಮೆಟೀರಿಯಲ್ಸ್ ಇಟ್ಟಿರ್ತೀವಿ, ಎಷ್ಟು ಇನ್ಸಿಡೆಂಟ್. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ಒನ್ the unit called Sabines is chosen to express absorption coefficient. One Sabine is the absorption by an open window of area of 1 meter square. So it is also called as a open window unit. Next, here Sabine's formula for reverberations time. So the scientist named Valen C. Sabine obtained a formula from its experiments to calculate reverberations time of a hall. How he is going to calculate? Through mathematically he is going to explain. So that one is we called as a expression derivation for Sabine's formula or obtain the expression for reverberation time antale ನಾವು ಕರ್ಕೊಂತೀವಿ. ಈಗ you consider one auditorium or a hall in which sound waves are produced and get reflected from the surface of the walls in the same auditorium. Let's V with the volume of the hall, S with the surface area of the hall, and distance between the two successive reflections from the wall is given by distance between the two successive reflections, D is equal to 4V by S. So in the volume we are going to discuss 4V by S. Let V be the velocity of the sound in the hall, then the time taken between two successive reflections is given by T1. Distance between two successive collisions. Successive collisions divided by velocity of the sound. Therefore, T1 is equal to D by V. D means distance, that is 4V by S divided by V. So we are getting a 4V by SV. So next, the average number of reflections of a sound from the wall in a time is given by N is equal to T by T1. So T by T1 here we already calculated previous 4V by SV. Substitute, we are getting a SVT by 4V. It is about the number of reflections comes out from the wall at a particular time durations. Let A of F be the fractions of sound observed at a single absorption. Then the fraction of sound reflected from the wall will be A1 minus AF. After two reflections, the fraction of sound reflected from the wall will be 1 minus AF square. So this one is the complete expression for maybe for 8 marks. So it is also very important expressions. Don't neglect. Just you find draw and also practice it more times to write. Similarly, after n reflections, the fraction sound reflected from the walls will be the 1 minus AF to the power of n. Last, let I naught be the initial intensity of a sound, IT be the intensity of a sound after a certain time. The relation between initial and after some time is given by IT is equal to I naught into fraction of sound reflected from the wall after a n reflections. Therefore, IT is equal to I naught into 1 minus AF to the power of n. Next we consider n is equal to SVT by 4V. Already we know it. Therefore, IT is becomes to I naught into 1 minus AF to the power of SVT by 4V. For reverberations, T is equal to capital T. Therefore, you see the previous this equation, it becomes to IT is equal to I naught into 1 minus AF of SV instead of small t. So we are going to write it as capital T by 4V. By the definition of reverberation time, already we know IT is equal to I naught into the power of minus 6. So then comparing both these two above equations, we are getting a 10 to the power of minus 6 is equal to 1 minus AF to the power of SVT by 4V. The solving these expressions of T, we get T is equal to 6.20303 minus 0.4V by SV log E of 1 minus AF. So then the T becomes to 55.272 into V by SV of minus of AF. Calculating of all these values, we are getting a 55.272 into V by SV of AF. But velocity of a sound at room temperature is equal to 350 meter per second. Therefore, so the V value is becomes to 350 meter per second. Calculating of these values with 350, we are getting a 0.1575 of AF. After knowing this concept, but the fraction of sound observed by the materials at a single absorption is given by A1. So AF is equal to A1S1 plus A2S2 plus A3S3 of ANSN divided by S1, S2, S3 plus S4 plus of Sn, where A1, A2 is the absorption coefficients of the materials in the hall, and S1, S2, S3 is the surface areas exposed to sound waves respectively. Then the above equation can be written as AF is equal to A1S1 plus A2S2 plus A3S3 of ANS1 by S1, S2, S3 of Sn. Summation of AS by S, say in equation number 4. So then substituting this equation number in the previous last equation, that is T, capital T is equal to 0.1579 V of 2AS by S into S. So here 2 cancel, then the remaining thing is 0.1579 V into sigma of AS. Therefore, T is equal to 0.1579 V by AS. So then here V is the volume of the hall and A is the absorption power of a sound in the hall. So then equation 5 is the reverberations time formula. So here reverberations time formula after calculating it. So now here we are going to discuss submarine's reverberations time formula. It says that reverberations time is, the reverberations time is directly proportional to the volume of the auditorium and also auditorium or hall. So second is, it is inversely proportional to the absorbing surface area of the materials in the auditorium or hall. Third one is inversely proportional to the absorption coefficients of the materials in the auditorium or hall. That means total absorption and transmissions through the open surfaces. Total absorption and transmissions through the open surfaces. So experiments have proven that for all with a volume is less than 350 meter cube, a reverberations time is 1.03 seconds is most suitable. Covering of wall of a hall with a material having a large absorption coefficient decreases the reverberations time. Reverberations time can be decreased by increasing the surface area in constructions like cinema halls. So we can observe the cinema hall, they are going to maintaining all these conditions. So acoustic conditions of buildings, ಏನೇನಿರುತ್ತೆ acoustic conditions of buildings ಅಲ್ಲಿ ಅಂತ ಅಂದ್ರೆ, so first one is ಅಂದ್ರೆ for example ಫಿಲಮ್ ಥಿಯೇಟರ್ಗಳೇ ಆಗ್ಬೋದು, ಅಥವಾ ಯಾವ್ದಾದ್ರು ಒಂದು ಹಾಲ್ ಆಗ್ಬೋದು, ಮಾಲ್ ಆಗ್ಬೋದು, ಅಥವಾ ಯಾವ್ದಾದ್ರು ಒಂದು ಆಡಿಟೋರಿಯಂ ಆಗ್ಬೋದು. So all these things, how they are going to maintaining to avoiding these reverberations. The quality of sound and loudness should be uniform throughout the entire hall or auditorium. So second one is there should not be any overlapping of sound. Third one is the presence or absence of audience should not affect the quality of sound. Resonance effect should be avoided. The hall should have a proper reverberations time. The external noise should not disturb the pursuing of the hall. Fifth one is there should not be any echoil effect. Echoing effect. So once again we will discuss one by one. I will tell you the quality of the sound and loudness should be uniform throughout the entire hall or auditorium. ಈ loudness of the sound uniform ಆಗಿತ್ತು ಅಂತಂದ್ರೆ, so at the time, so it will be going to distribute in entire hall or auditorium. It avoids the echo from the absorption coefficients. There should not be an overlapping of sound. That one you are maintaining some walls in the different order, some instruments in the different order. So we are going to maintaining a overlapping of sounds. If the sound will be comes reflection back, means they get the collisions. We are going to maintain or avoid the collisions of these conditions. The collision is nothing but the overlapping. The overlapping of sounds here we are going to maintain. Third one is the presence of or absence of audience should not affect the quality of sound. Resonance effect should be avoided. If the resonance will be comes out here, means so we can't get the sound maximum or clear. So we have to avoid this resonance in this hall to maintain so many different kinds of absorption coefficients in the hall. That means the presence or absence of audience should not be effect of quality of sounds. The hall should have a proper reverberations time. So uniform reverberations time reach agotara nodkontaru. Then only it avoids the external noise should not be disturbed the proceeding of the halls. There should not be an echoing effect. So after knowing this one, so factors affecting the acoustics of buildings. So first one is following factors influence the acoustic of the buildings. So the first thing is optimum reverberations time. Optimum reverberations time, first one. So what is the meaning of optimum reverberations time? Persistence or prolongation of sound hall even after the sound is stopped is known as reverberations time. Optimum reverberation time can be achieved by providing a few open windows, using a heavy curtains with the folds, covering floor with the carpets, covering ceilings and halls with a good absorbent materials. To avoiding all these things, here we can get it a optimum reverberations times. So second one is adequate loudness and uniform distribution of sound. So it is produced on the ears is the loudness. Uniform distribution of loudness is necessary for satisfactory hearing. Loudness can be increased by using a large sounding boards behind the speakers. suitable absorbent by using a periodic walls in the hall. So that is the maintaining a adequate loudness and uniform disturbance. Third one is focusing. So focusing also very important point. Sound waves falling on the curved surface or curved surface of the buildings after reflection get focused to the point. Get reflection focused to the points. Intensity of sound is maximum at those points. ಇಲ್ಲಿ ರಿಫ್ಲೆಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಕರ್ವ್ ಪಾಯಿಂಟಲ್ಲಿ, ಅಲ್ಲಿ ಇಂಟೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಅಂಡ್ ಝೀರೋ ಅಟ್ ದಿ ಪಾಯಿಂಟ್ಸ್ ಅಂಡ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಎ ಫೋಕಸಿಂಗ್ ಎಫೆಕ್ಟ್. ಒಂದೊಂದು ಪಾಯಿಂಟಲ್ಲಿ ಝೀರೋ ಅನ್ನುತ್ತೆ ರಿಫ್ಲೆಕ್ಷನ್. ಸೊ ದಟ್ ಪಾಯಿಂಟ್ಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಫೋಕಸಿಂಗ್ ಎಫೆಕ್ಟ್. ದೇರ್ ವಿಲ್ ಬಿ ಆನ್ ಅನ್ಈವನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆಫ್ ಸೌಂಡ್ ಇಂಟೆನ್ಸಿಟಿ ಅಂತ ಪಾಯಿಂಟ್ ಒಳಗೆ we can't get a maximum uniform intensity, uneven, different intensity, it will comes out. If there is a curved surface or equal, there is no curved surface in the shell, in the hall, no. So avoid curved surfaces, cover them with a suitable sound absorbing materials. Curved surface in the again. So here we have to maintain this. Next is absence of echoes. This one. The echoes are produced due to reflections of sound from the walls and ceilings. That is very important. To control echoes, reflections of sound from the walls should be minimizing by covering the walls with a suitable sound absorbing materials. Next one is echolocation effect. It occurs due to series of reflected sound waves consisting of simple echo to the original sound. This is called echolocation effect. Echolocation effect can be eliminated by covering surface. That means using a floors or stairs here. So with a good absorbing materials like a carpets. So next is absorption of resonance. So windows, panels, sections of wooden partitions which are loosely fitted start vibrating, creating extra sounds. ಇವೆಲ್ಲ ನಾವು ಕರೆಕ್ಟಾಗಿ ಮೇಂಟೈನ್ ಮಾಡಬೇಕು. If there is a resonance for any audio frequency note, the intensity of a note will be entirely different from the intensity desired. Such resonant vibration should be damped. So we have to maintain this. Last one is elimination of external noise. So sound from a outside could enter the hall through a windows or doors and produce undesirable noise. ಹೊರಗಡೆಯಿಂದ ಸೌಂಡ್ ಬರಬಾರ್ದು. It should not comes out from the sound outside from this building. If it is comes means here we are getting a chances for a resonance. So far we should be avoid to come out the sound system from the outside of the buildings. To avoiding these kind of things, sound from the outside could enter the hall through a windows and the doors and produces undesirable noise. So this exterior noise may be minimized by using a double or triple doors and windows, each with its own framework. So to maintaining a different kinds of a doors, double doors, triple doors or curtains or a different reflectors. So maintaining all these different kind of things, so we can make it a avoiding of influencing of acoustics of the building. So these are all here we are going to maintain. So we can observe in film theaters, because they are using film theaters in commercial. So the persons, they are expecting very clear noise. For that purpose, they are maintaining all these 7 factors. Then only we can get the very good voice from a film, from a sound film. So far in auditorium or in a film theaters, they are maintaining properly all these things. Okay. Next is finally, so I have referred these concepts using so many different kinds of textbooks. One is from a Sundarajan, Sir is explained through a college physics book published in the United Publishers. Similarly, Subramaniam is also written as a textbook of optics referred in a Chan publication. Similarly, the remaining four different authors explained same concept in a prescribed textbook based on the syllabus planned by the Tumkur University. One is Mangala Gauri, second one is Nagbhushan Sir, third one is Ramakrishna, sixth one is I was referred through a slide shares, and also with using so many different kinds of journals and also referred books. So it's about today's topic. Thank you one and all.